Welcome to The Explainer. Today, we're becoming economic detectives. We're not solving a crime exactly, but we are uncovering hidden truths. Our tool of choice? A little something called econometrics. And our scene? Well, it's the whole complex world of data. So, let's get started. So, every investigation has to start somewhere, and ours begins with a mystery that honestly impacts all of us, from our grocery bills to the global economy. It seems simple at first glance, but just like in any good case, the real clues are hiding in plain sight. You'd think, right? In a perfect world, you could just write up a simple formula, you add this much fertilizer, that much water, and boom, you get a predictable amount of crops. But we all know the real world is, well, it's messy. You've got unexpected rain, a sudden pest problem, the quality of the soil itself. All these things just complicate the picture. So while economic theory gives us a nice, clean map, it doesn't always match the actual territory. And that is exactly where econometrics comes in. Think of it like forensic science, but for economists. It takes those really elegant economic theories, mashes them together with mathematical models and some serious statistics, and then applies it all to that messy, real-world data to find actual numerical answers. It's the toolkit we use to find the real story hiding in the numbers. This gets us to the absolute heart of the challenge, which is understanding the huge difference between a model that lives nicely in a textbook and one that has to, survive out in the wild. Just take a look at this comparison. An economic model is like a perfect blueprint for a building, right? It describes this ideal, exact relationship. But an econometric model, that's the building after it's been built. It has to account for all that real-world chaos, the randomness, the unpredictability. It's theory plus a very healthy dose of reality. Okay, so if the real world is this chaotic, how can we possibly build a model that's actually reliable? How do you account for all that randomness? Well, the secret isn't to ignore the chaos. It's to embrace it with one really clever idea. So instead of just pretending their models are perfect, econometricians do something brilliant. They build the imperfection right into the equation itself. They straight up acknowledge that things they can't measure are always going to play a role. And this crucial little piece is called the disturbance or error term. And this is the key. The stochastic term, which you'll often see as the Greek letter epsilon, is basically a catch-all basket. It's where we toss all the things we can't, or maybe just don't, measure directly. So for our crop yield mystery, this basket could be holding stuff like sudden weather shifts, the farmer's individual skill, or even just plain old random luck. It's the model's way of being humble and saying, look, I can explain a lot, but I can't explain everything. All right, so now we have a framework that actually accepts randomness. So what's next? How do we use it to solve our mystery? Well, like any good detective, we can't see the underlying relationship with our own eyes. We have to work backward from the clues it leaves behind. This whole idea of moving backward is really the essence of what we call regression analysis. Think about it this way. A true relationship already exists out there in the world, like the real factors that affect crop yield. That relationship is what generates the data we see. Our job as detectives is to take that data and work our way backward to figure out what the original model was. And that's a really important distinction. The model creates the data, not the other way around. Now, to work backward effectively, you need the right kind of clues. Any good detective knows that different types of evidence tell different parts of the story. In economics, our evidence is data, and it comes in a few very distinct forms. First up, you've got time series data. This is like looking at a single suspect's activity log over many, many years. You're tracking one thing, let's say a country's unemployment rate, month after month from 1990 to 2010. This helps you spot trends and patterns for that one single thing over a long period of time. Next up is cross-section data. This is like walking into a room full of different people and interviewing all of them on the very same day. You're getting a snapshot of many different individuals, but at one specific moment in time. For example, looking at the income and education of 500 different people, but only for the year 2023. It's fantastic for seeing the variation across a whole population. And finally, there's panel data, which is kind of the best of both worlds. This is like interviewing the exact same group of 500 people every single year for 20 years. It combines the time series and the cross-section approach, which lets you track the same individuals over time. This is how we can answer really deep questions like, how does a college degree affect a specific person's income over their entire life? It's incredibly powerful stuff. Okay, so with our case defined and our different types of clues in hand, we're ready to follow a structured process. This isn't just guesswork, it's a systematic investigation, a step-by-step plan of attack. Pretty much every regression analysis is going to follow these fundamental steps. You start with a problem, defining the mystery you're actually trying to solve. Then you choose your variables. Those are your main suspects. After you collect the data and specify a model, you fit that model to the data you have. But the investigation doesn't stop there. That last step, validation, is absolutely critical. It's where you double and triple check your work to make sure your conclusions are solid and not just some random coincidence. So after all this work, defining the problem, gathering the clues, building the case, what's the payoff? What can we actually do with all this hard-won knowledge? And this is why it all matters so much. The goals of econometrics really boil down to three main things. First, you want to turn a vague idea into a specific, testable model. Second, you estimate and test that model against reality to see if it even holds up. And third, and this is the big one, you use that validated model to do amazing things, forecast what might happen in the future, or help policymakers make better, data-driven decisions that affect all of us. Think about it. From understanding what really drives stock prices, to figuring out the impact of a new law, to predicting the effects of climate change, this detective's toolkit is just so incredibly versatile. It's a powerful way of working backward from the clues the world gives us to really understand the hidden forces that shape it. So the only question left is, what mystery would you choose to solve?